Okay, explanation time. Inertia is the resistance of any physical object to any change in its velocity. It is a force that causes something moving to continue moving, and that causes something not moving to continue not to move. Simple enough, right? Now, this whole concept was quantified in Newton's first law of motion, but we'll get into all of that later. I know you might be wondering to yourself, what is the measure of inertia? The short answer? It's mass. Okay, let me explain. Objects of higher mass resist changes in motion more than objects of lower mass. Let's use a ball as our example here. A heavier ball, which is one made out of titanium, or whichever heavy metal you wish to use, will take more of a push to start rolling. A styrofoam ball of the same size, on the other hand, may be set in motion by a puff of air because of its low mass. Essentially, the higher the mass of an object, the higher the amount of inertia experienced, and vice versa. This is where the Newton's first law of motion comes into picture. What you need to know about this law is that it can be deducted into 2 points. 1. An object that is not moving will not move until a force was acted upon it. And 2. An object that is in motion will not change velocity or stop until a force was acted upon it. The first point seems relatively obvious to most people, and let me demonstrate you the examples we have. This is Mr. Ashraf. Being strapped tightly to the car, what happens with Mr. Ashraf just now is that he was in a state in which he shares the same state of motion as the car. As the car accelerates, he accelerated with it. As the car decelerates, he decelerated with it. And as the car maintains a constant speed, he also maintained a constant speed. When the car decelerates, Mr. Ashraf would no longer share the same state of motion as the car. Thus, he was momentarily jerked forward due to the inertia that happened, before going back to his original state. But hey, it's a good thing he wore a seatbelt though. Imagine if he didn't wear it. If he were to crash his car to a wall or suddenly applying brakes on his car from speeding, he would definitely fly out the car and oh dear. Excuse me, what? Ah, that good old flicking money under any object kind of trick. We always do that back when we were kids now, don't we? Back then, we never really thought of the physics behind that trick. But good news. Now you know. Now, to explain the inertia that had happened to that rock is easy. When you flick the money swiftly under the rock tends to want to stay put and then falls when the money is no longer under it to support the rock. When you do so, you allow gravity, which is an outside force, to act on it and drop it on the bottle cap. Believe me, you can try and do it on just about anything, and I can prove it to you now.
Asap masuk tak?
And another one.
Okay, 1, 2, 3. Again.
With that being said, I would like to thank you all for tuning in. Sorry if this video ends so abruptly. I mean, I know this video would deserve a better ending than this, but I don't know what to do about the conclusion part of this video, so I decided to cut it off for now. Again, I would like to thank you guys for tuning in, and I hope you learned something. I'll catch you guys next time. Peace.